Hey everyone, and welcome. Today we are diving into probably the most incredible piece of technology you will ever own, your own eyes. We're going to explore the amazing science behind how we see our beautiful, colorful world. So let's get right into it. I mean, really, have you ever stopped to think about it? You've got this super advanced auto-focusing, full-color camera built right into your head. So how in the world does it take all the light out there and turn it into the images you see? Well, let's break the whole thing down. All right, first things first, we're going to look at the basic parts. And honestly, the best way to get it is to think of your eye as a living, breathing camera, where every little piece has its own super specific job to do. Okay, so when light first zips towards your eye, the very first thing it hits is the cornea. This is like the clear front window, or even better, the main lens of the camera. And get this, it does most of the heavy lifting. About 70% of the focusing happens right here. This first big bend of light is what kicks off the whole process of seeing. Next, we've got the iris. You know, the part that gives your eyes their color, whether they're blue, brown, or green. Its main job is to control the size of the pupil, that little black dot right in the middle. When it's super bright out, the iris makes the pupil tiny to let less light in. And when it's dark, it opens it up wide to let more light in. It's basically your eye's own automatic brightness control. Tucked right behind the pupil, we have the crystalline lens. Now, if the cornea did the big, rough focus, this little guy is all about the details. It's the master of fine-tuning. It actually changes its shape to make sure the picture is perfectly sharp, whether you're looking at a mountain miles away or the words on this screen. And finally, the light reaches its destination, the retina, way at the back of the eye. Think of it like the sensor in a digital camera or the screen in a movie theater. It's packed with millions of light-sensitive cells that catch the light and bam, turn it into an electrical signal. That signal then zips down the optic nerve to your brain, which does the final magic trick of making sense of it all. It's just wild, isn't it? So we know the lens fine-tunes the focus, but how does it do it so fast and without you even thinking about it? Well, this is where the real magic of the eye comes into play. It's called the power of accommodation, which sounds super technical, right? But the idea is actually pretty simple. It's just your eye's built-in natural autofocus system. It's the amazing ability of your eye's lens to physically change its own shape, to focus on things whether they're near or far, and it does it in an instant. So how does that work exactly? Well, it's all about these tiny little muscles. When you're looking at something way off in the distance, those muscles just chill out. They relax, making the lens flatter and thinner. But the second you look at something up close, like your phone, those same muscles squeeze and contract, making the lens thicker and more powerful. Your eyes are basically doing tiny little workouts all day long without you even noticing. Of course, no system is absolutely perfect. And sometimes this really delicate focusing system can have a few, let's call them glitches. But the good news is, these common bugs in our vision are usually just simple focusing problems that we've gotten really good at fixing. First, there's myopia, which you probably know as nearsightedness. This is when you can see things up close just fine, but things far away are a blurry mess. The problem is that the eye is actually a little too powerful. It's focusing the light in front of the retina instead of right on it. The fix? We use a concave lens in glasses, which spreads the light out just a tiny bit, pushing that focal point back onto the retina where it belongs. And on the flip side, you've got hypermetropia, or farsightedness. You guessed it, it's the exact opposite problem. Distant objects are clear, but trying to read a book is tough. This time, the eye isn't quite powerful enough, so the image wants to focus behind the retina. The solution is just as straightforward. A convex lens gives the eye that little extra boost of focusing power it needs to pull the image forward, right onto the retina. Simple as that. So, we've talked about the lenses in our eyes and the lenses in glasses, but what happens when nature itself creates millions of tiny temporary lenses in the sky to put on a show? Well, that's how we get one of the most beautiful sights on Earth. The magic word here is dispersion. It sounds complicated, but it's not. Here's the big secret. White sunlight isn't actually white. It's a secret mix of all the colors you can imagine. Dispersion is simply the act of splitting that white light open so we can finally see all the colors that were hiding inside. So check this out. Every single little raindrop acts like a tiny prism. Step 1. Sunlight enters the drop and bends. Step 2. As it bends, it splits apart into all its different colors. Step 3. Those colors then bounce off the back of the raindrop like a mirror. And step 4, as the light leaves the drop, it bends again, fanning those colors out into that perfect arc. Multiply that by millions of raindrops, and boom, you've got a rainbow.
All right, from tiny raindrops, let's zoom all the way out to our entire atmosphere. Because the way light interacts with the air itself is the reason for some of the biggest, most beautiful colors in our world. This is the classic question, right? Every kid asks it, and the answer is just fascinating. And no, it's not because the air itself is blue. It's all about how light gets scattered around.
So here's the deal. Our atmosphere is full of these tiny, invisible gas molecules. Think of it like a giant pinball machine. Now, blue light has a very short, zippy wavelength, which means it's the perfect size to get bounced and scattered around by all those little air molecules. It gets knocked in every direction. So when you look up, what you're seeing is that scattered blue light coming at you from all over the place. Okay, so if blue gets scattered everywhere, why are sunsets red and orange? Great question. It's the same science, just a different angle. When the sun is low on the horizon, its light has to travel through way more atmosphere to get to you. And during that long journey, almost all of that blue light gets scattered away from your direct line of sight. So what's left to make it all the way to your eyes? The longer, tougher wavelengths, the reds and the oranges. And as we wrap things up, I want to go back to that very first part of the eye we talked about, the cornea. Here's something truly incredible. That clear window to the world can be donated. And just one person's donation, one pair of eyes, can give the gift of sight to as many as 4 people. It's a really powerful reminder of just how precious our vision really is. So after hearing all this, maybe take a moment today to just look around. Really look at the world. The blue sky, the colors, the face of a friend, and think about that incredible journey light takes just to make that picture in your head. It really makes you wonder, doesn't it? What's the most amazing thing your own personal camera has ever captured? Thanks for joining me.